Hi everyone, welcome back to the Function Junction, where we make math simple and easy to understand. Today we'll learn how to write equations of parallel and perpendicular lines. By the end of this video, you will be able to identify parallel lines, find perpendicular slopes, write equations of both line types, and avoid common mistakes. In the last few videos, we learned how to graph linear equations, how to find slope, and how to write equations of lines. Today we're taking one step further. We'll be learning how to write equations of lines that are parallel to one another or perpendicular to another line. This is one of the most important applications of slope, because slope doesn't just tell us how steep a line is, it also controls the direction of the line. And once we learn how slope affects the direction, we can create entirely new equations. Let's start with understanding parallel lines. Parallel lines are lines that never intersect. No matter how far you extend them, they stay the same distance apart forever. But why does that happen? It happens because they rise and fall at the same rate, which means that they have the same slope. For example, if one line rises 2 units for every 1 unit to the right, and another line does the exact same thing, the lines will move together perfectly. Neither line will catch each other. That's why parallel lines must have identical slopes. It's important to note that although they have the same slope, parallel lines can have different y-intercepts. This means that they can start in different places, but as long as the slope stays the same, they will remain parallel. Let's look at our first example. Write the equation of a line parallel to y equals 3x plus 5 that passes through the point 2 minus 1. Step 1 is to identify the original slope. To do so, we need to remember slope-intercept form, where y equals mx plus b, and m represents the slope. Looking at our given equation, we can see that m equals 3. Step 2 is to determine the new slope. Since the new line must be parallel, it needs to have the same slope. Therefore, we know m equals 3. This is the most important rule for parallel lines. Same direction equals same slope. Step 3 is to use point-slope form. We now have the slope and we were given the known point. This means that we can use point-slope form. From our previous lessons, we know the equation for point-slope form is y minus y1 is equal to x times by x minus x1. We substitute our values from our known point into the equation and simplify it till we get y equals 3x minus 7. In step 4, we can graph the two lines to get a visual representation and confirm that the two equations are in fact parallel with one another. As we can see, our original line has a y-intercept of 5 and rises 3 units and moves to the right 1 unit. For our parallel line, it still has a rise of 3 and a run of 1, however, the y-intercept is at minus 7. Looking at the two lines visually on the graph from step 4, we can confirm that they run parallel to one another. As we can see, our original line has a y-intercept of 5 and rises 3 units and moves to the right 1 unit. For our parallel line, it still has a rise of 3 and a run of 1. However, the y-intercept is at minus 7. Looking at the two lines visually on the graph from step 4, we can confirm that they run parallel to one another. Let's move on to perpendicular lines. Perpendicular lines intersect at a perfect 90-degree angle. Unlike parallel lines, these lines move in completely different directions. And because of that, their slopes must have a special relationship. Perpendicular slopes are negative reciprocals. This phrase confuses a lot of students at first, so let's break it down carefully. Let's start with what is a reciprocal. A reciprocal of a fraction is simply the numerator and denominator flipped. For example, if we have the fraction 2 over 3, to find its reciprocal, we flip the top and bottom numbers and get 3 over 2. Now, what is a negative reciprocal? To find the perpendicular slope, we need the negative reciprocal, which is the reciprocal slope but with a negative in front of it. For example, if we have the fraction 2 over 3, its negative reciprocal would be negative 3 over 2. It's important to note that if we started with a negative slope, the slope of the perpendicular line would become positive. This relationship creates the exact amount of directional change needed for a 90-degree angle. One line rises while the other falls in the opposite way. Let's take a look at an example. Write the equation of a line perpendicular to y equals 2x plus 1 that passes through the point 4, 3. Step 1 is the same as before. we find our original slope, which in this case, m equals 2. Step 2 is a little different. To find the perpendicular slope, we need to find the negative reciprocal of our original slope. In this case, we would get negative 1 over 2. Step 3 is to use point-slope form. We now have the slope and we were given a known point. This means we can use point-slope form. We substitute our values from our known point into the equation and simplify it till we get y equals negative 1 over 2x plus 5. And step 4, we can graph the two lines to get a visual representation and confirm that the two equations are in fact perpendicular with one another. Let's take a look at some common mistakes that students make that can be avoided. The most common mistake with perpendicular lines is flipping the sign of the slope but not finding the reciprocal. Likewise, another common mistake is finding the reciprocal of the slope but not flipping the sign. Remember, to change the direction of the line to be 90 degrees away, we need the slope to have the opposite sign. Lastly, a common mistake is using the same slope for a perpendicular line. Same slopes are only used for parallel lines. Let's summarize what we learned in this lesson. Equations of parallel lines have the same slope and the lines never intersect, while the slope of a perpendicular line is a negative reciprocal and the lines intersect at a 90-degree angle. Congratulations, we successfully learned how to find the equations of parallel and perpendicular lines. If you like this video, make sure to subscribe. Also, make sure to check out our other videos to continue your function junction journey. See you next time.